How did people living at the edge of the Arctic Circle, without modern insulation, electricity, or central heating, manage to trap warmth through months of darkness, ice, and howling winds, and not just survive, but build families, communities, and entire civilizations? To understand how the Vikings stored heat, we must first abandon the modern idea of heating a house, and instead enter a world where warmth was not produced constantly, but captured, slowed, and guarded like a precious resource. For the Norse, heat was not something you turned on. It was something you earned, stored, and protected through intelligent use of stone, earth, water, and time itself. Every wall, floor, and hearth was part of a system designed to absorb warmth when it was available and release it slowly when the cold returned. This was ancient thermal engineering, born not from theory, but from generations of hard-earned survival. The Viking world was unforgiving. Winters were long, daylight was scarce, and temperatures often dropped well below freezing. Wood was valuable, time-consuming to gather, and could never be wasted. A poorly designed home meant more fuel burned, more labor spent, and greater risk of illness or death. As a result, Viking builders learned to work with materials that could hold heat long after the fire died down. Stone, earth, and water were abundant, durable, and, most importantly, capable of storing thermal energy. These materials became the silent guardians of warmth through the night. Stone was one of the most important elements in Viking heat storage, not because it produced warmth, but because it remembered it. Thick stone walls absorbed heat from the central hearth throughout the day and evening. As the fire burned, radiant heat slowly penetrated the stone, warming it from the inside. When the flames faded and embers cooled, the stored warmth did not vanish. Instead, the stone released it gradually back into the living space, stabilizing temperatures and preventing sudden drops. This meant that even hours after the fire was extinguished, the interior of a Viking home remained livable. But Viking builders understood something even more subtle. Stone alone was not enough. Exposed stone could bleed heat into the outside air if not protected. That is why stone was often combined with earth. Many Viking longhouses were partially sunken into the ground, with floors dug below the frost line and walls reinforced with packed soil. Earth is a remarkable thermal mass. Below the surface, temperatures remain relatively stable year-round. By anchoring their homes into the ground, Vikings insulated themselves from extreme cold and wind while using the earth itself as a vast heat reservoir. This semi-subterranean design was no accident. When heat from the hearth warmed the interior air, some of that warmth transferred into the surrounding soil. The ground absorbed it slowly, storing it much like stone. At night, when the air temperature dropped, the earth released its stored warmth back into the structure. This created a thermal buffering effect, smoothing out the sharp temperature swings that would otherwise make winter nights unbearable. In essence, the Viking home became part of the landscape, borrowing the earth's natural stability to protect human life. The placement of the hearth was central to this system. In most Viking longhouses, the hearth sat at the heart of the structure, not against a wall. This allowed heat to radiate evenly in all directions. Smoke rose upward and escaped through a roof vent, but much of the radiant heat spread horizontally, warming walls, floors, stones, and even wooden furniture. Every object in the home became a secondary heat store. Benches, bed platforms, and storage chests absorbed warmth during the day and released it slowly through the night. Water, though less obvious, played an equally important role in Viking heat management. Water has an extraordinary ability to store thermal energy. In Viking homes, water existed in many forms: stone-lined wells, barrels, cooking vessels, and even damp earth beneath the floors. Heated water used for cooking or bathing retained warmth long after use. Stone pots and cauldrons, once removed from the fire, continued to radiate heat into the surrounding space. Even moisture trapped within earthen walls contributed to thermal stability by absorbing heat and releasing it gradually. In bathhouses and saunas, structures common in Viking settlements, the principle of heat storage reached its peak. Stones were heated intensely in a fire, then water was poured over them to produce steam. These stones did not cool quickly. They acted as massive heat batteries, radiating warmth for hours. The same principle applied on a smaller scale within homes. Heated stones placed near sleeping areas or under benches provided localized warmth long after the hearth fire was reduced. The Viking understanding of heat was deeply tied to rhythm and routine. Fires were not kept roaring endlessly. Fuel was too valuable. Instead, heat was concentrated at key times, early morning and evening, when families gathered, cooked, and worked indoors. During these periods, thermal mass materials absorbed as much warmth as possible. At night, when fires were damped down to embers, the stored heat carried the household through the coldest hours. This approach transformed intermittent fire into continuous comfort. Roof design also played a crucial role in protecting stored heat. Viking roofs were often layered with turf, thick slabs of grass and soil placed over wooden frames. Turf roofs added enormous thermal mass and insulation. During the day, they absorbed heat rising from the hearth. At night, they slowed heat loss to the sky. Snow accumulating on turf roofs further enhanced insulation, trapping warmth below. What might appear primitive was, in reality, an advanced understanding of how to work with natural materials to control energy flow. Air movement was carefully managed as well. Viking homes were deliberately dark and smoky, not because they lacked skill, but because fully venting smoke would also vent heat. Roof openings were small and adjustable. Doors were low and narrow, forcing people to stoop, which reduced heat loss. Entryways sometimes included short passages or windbreaks that prevented cold air from rushing directly into the living space. Every design choice supported the same goal: keep stored heat from escaping too quickly. Perhaps most remarkable is that these systems required no measurements, equations, or written plans. Knowledge passed through observation and experience. Builders knew which stones held heat longest, which soils insulated best, and how deeply to sink a floor to escape frost. Families learned when to stoke the fire and when to let it die. Children grew up understanding warmth not as a convenience, but as something fragile that demanded respect. By combining stone, earth, and water into a unified thermal system, the Vikings turned scarcity into strength. They did not fight the cold with constant fire. They slowed it with mass, depth, and patience. Their homes breathed slowly, warming and cooling in harmony with the seasons rather than against them. This ancient engineering allowed entire communities to endure winters that would otherwise be lethal. In the modern world, surrounded by steel, glass, and instant heat, it is easy to underestimate the sophistication of these solutions. Yet many of the principles the Vikings relied upon, thermal mass, passive heating, earth sheltering, are now being rediscovered in sustainable architecture. What was once a matter of survival has become a blueprint for efficiency. And it all began with stone walls that remembered warmth, earth that guarded it, and water that quietly carried heat through the long northern night. As winter deepened and the sun's arc across the sky grew shorter, the Viking home became not just a shelter, but a carefully managed thermal environment where every surface, material, and daily habit worked together to conserve warmth. Heat storage was never isolated to a single element. Stone, earth, water, wood, air, and human activity formed an integrated system that functioned continuously, even when no flames were visible. The brilliance of this system lay in its ability to transform brief moments of intense heat into long hours of steady comfort. One of the most underestimated aspects of Viking heat storage was the floor itself. Unlike modern raised floors, many Viking longhouses featured compacted earth floors, sometimes mixed with clay, ash, gravel, or crushed stone. These floors were dense and heavy, ideal for absorbing radiant heat from the hearth. As people gathered around the fire, warmth soaked downward into the ground beneath their feet. This was not accidental. Over time, repeated heating cycles slowly raised the temperature of the subsoil inside the structure, creating a warm thermal core that resisted freezing. Even when outside temperatures plunged, the interior ground remained comparatively warm, preventing cold from creeping upward into the living space. Sleeping arrangements were designed around this stored warmth. Viking families did not sleep in separate rooms, but on raised wooden platforms lining the walls. Beneath these platforms, air circulation was limited, allowing warm air to pool and remain trapped. The wooden boards absorbed heat from the room and from the bodies resting above them. In some cases, stones heated during the day were placed beneath or beside sleeping areas, releasing warmth through the night. Furs and woolen blankets trapped body heat, but it was the slow release of stored thermal energy from the building itself that prevented the bitter cold from reclaiming the space before morning. Water continued to play a quiet but powerful role in this process. Cooking was done in large iron or stone vessels that held heat long after meals were finished. A pot of stew simmered for hours, its contents slowly absorbing thermal energy. When removed from the fire, the hot liquid became a mobile heat reservoir, radiating warmth into the air as families ate and worked nearby. Even after the food cooled enough to consume, the vessel itself remained warm, contributing to the overall heat balance of the home. In some regions, Vikings used stone-lined pits or storage spaces where warmth could accumulate. These pits, often near the hearth, captured heat that traveled downward through the floor. Stored food benefited from this stable temperature, protected from freezing without exposure to open flames. This demonstrated a sophisticated understanding of how heat migrates through materials and how to exploit that movement for both comfort and preservation. The walls of Viking homes were rarely uniform. Timber frames were packed with turf, clay, moss, and stone, creating thick composite structures with high thermal mass. During periods of intense heating, warmth penetrated these layers slowly. When the fire died down, the same layers slowed heat loss, releasing warmth back into the interior at a controlled pace. Moisture trapped within these walls further enhanced this effect. While excess dampness was dangerous, controlled moisture increased the heat capacity of the structure, allowing it to store more energy without increasing fuel consumption. The exterior environment was also part of the heat storage strategy. Snow, often seen as an enemy, became an ally. Snow piling against the walls and roof acted as a natural insulating blanket, trapping heat inside. Viking builders did not clear snow away unless necessary. They understood that a snow-covered home retained warmth far better than one exposed to icy winds. The thermal mass of the walls, combined with this insulating layer, created a stable interior climate even during severe storms. Daily routines were synchronized with the thermal behavior of the house. Heavy physical tasks were performed during daylight hours when the hearth burned strongest. Human bodies added heat to the interior, raising temperatures and charging the thermal mass of the structure. In the evening, activities slowed. The fire was reduced to glowing embers, not extinguished, allowing just enough heat to maintain warmth while conserving fuel. Overnight, stored heat carried the household through until morning. The animals that shared Viking farms were also part of this system. In some longhouses, livestock were housed in adjoining sections separated by wooden partitions. The body heat of cattle, sheep, and goats contributed significantly to the overall warmth of the structure. Heat generated by animals seeped through walls and floors, warming adjacent living areas. This arrangement was not merely convenient. It was a calculated use of biological heat storage, turning life itself into a thermal resource. Ventilation was managed with extraordinary care. Smoke holes and small vents allowed enough airflow to prevent suffocation while minimizing heat loss. Smoke itself had insulating properties, filling the upper spaces of the longhouse and reducing convection currents that would otherwise draw warm air out. The smoky haze also helped preserve wooden beams and deter pests, further protecting the integrity of the heat-storing structure. Water stored in barrels and troughs rarely froze indoors, even during extreme cold. The combination of stored heat from the hearth, thermal mass of the building, and stable ground temperatures kept liquids above freezing. This was critical for survival. Access to unfrozen water meant fewer trips outside into deadly conditions and reduced energy expenditure. Every saved movement, every retained calorie, was part of the broader strategy of endurance. Over generations, Vikings refined these techniques through trial and observation. Homes were repaired and rebuilt on the same sites, allowing builders to learn how specific soils, stones, and layouts behaved over time. Knowledge passed not through written manuals, but through lived experience. Elders taught younger generations where to place stones, how thick to pack turf, and how long to maintain a fire before letting the house's stored warmth take over. What emerges from this system is not a crude attempt to fight the cold, but a dialogue with it. Vikings accepted that heat would always be limited. Instead of chasing constant warmth, they learned to slow its escape, stretching every ember into hours of comfort. Stone absorbed, earth stabilized, water moderated, and living beings contributed their share. Together, these elements formed a resilient network that transformed fleeting heat into enduring shelter. This approach allowed Viking communities to thrive in regions that would otherwise seem uninhabitable. It supported childbirth, craftsmanship, storytelling, and social bonds through months of darkness. Warmth was never abundant, but it was reliable, predictable, and shared. And in that reliability lay the true genius of Viking heat storage, an ancient engineering system built not on excess, but on understanding the quiet power of mass, time, and balance. As the Viking world evolved, so too did the refinement of their heat storage strategies, shaped by geography, available materials, and centuries of lived experience. From coastal Norway to inland Sweden, from Iceland's volcanic terrain to the settled edges of Greenland, the same core principles persisted. Absorb warmth when it is available, slow its escape, and allow the building itself to become the primary source of heat long after the fire has faded. What changed were the details, the thickness of walls, the depth of floors, the type of stone, and the way water and earth were woven into daily life. In volcanic regions such as Iceland, Vikings took advantage of basalt stone and naturally warm ground. Basalt, dense and slow to release heat, was ideal for hearth surrounds and interior walls. Homes built in these regions often felt warmer than those of similar size elsewhere, even with the same amount of fuel burned. In some areas, warm groundwater and geothermal steam subtly increased ground temperatures beneath dwellings, enhancing the thermal stability of floors. While the Vikings may not have fully understood the geological mechanics, they clearly recognized the benefits of building where the earth itself offered warmth. In Greenland, where timber was scarce and cold more extreme, turf and stone construction reached its highest sophistication. Walls were built astonishingly thick, sometimes over a meter wide. Composed of alternating layers of stone and sod, these walls acted as massive thermal batteries. Heat from the hearth penetrated slowly, but once warmed, these structures resisted cold for days. Even after fires were extinguished during storms or fuel shortages, indoor temperatures declined gradually rather than catastrophically. This slow thermal decay could mean the difference between survival and death. Water management in these environments became even more critical. Snow was melted deliberately and stored indoors in stone-lined basins. These basins absorbed heat from the room, preventing rapid freezing. As temperatures dropped, the water released stored warmth back into the surrounding air before finally turning to ice. This process acted as a thermal buffer, delaying dangerous temperature drops. Even ice itself, once formed, slowed further heat loss due to the energy required for phase change. A phenomenon Vikings exploited instinctively, long before it was scientifically described. The communal nature of Viking life further enhanced heat retention. Longhouses were not solitary dwellings but social centers. Multiple families, workers, and guests shared a single structure. The combined body heat of dozens of people significantly raised indoor temperatures, especially during feasts, winter gatherings, and craftwork sessions. These social events were timed not only for cultural reasons, but also for thermal efficiency. A full hall meant a warmer hall, charging the walls, floors, and roof with additional heat that would linger long after the gathering ended. Clothing and interior design also played subtle but important roles in the broader heat storage system. Wool, fur, and layered textiles were not just worn but hung along walls, draped over benches, and stored near sleeping areas. These materials absorbed heat from the air and from human bodies, then released it slowly. Hanging textiles reduced drafts and added insulation to stone and turf walls, effectively increasing the thermal mass of the interior environment. The home became layered not just structurally, but thermally. Firewood selection and fire management were themselves forms of heat engineering. Dense hardwoods burned longer and hotter, ideal for charging thermal mass. Softer woods ignited quickly, providing immediate warmth but less lasting heat. Vikings learned to combine fuels strategically, starting fires with fast-burning wood and sustaining them with dense logs that maximized heat absorption in stone and earth. Ash from these fires was not discarded casually. It was spread across floors to reduce moisture, increase thermal density, and reflect heat upward. Over time, the very layout of settlements reflected an understanding of shared heat storage. Homes were clustered close together, reducing wind exposure and creating microclimates within villages. Shared walls and windbreaks limited heat loss. Paths were aligned to minimize snowdrifts against entrances, while buildings shielded one another from prevailing winds. In extreme climates, even a small reduction in heat loss multiplied survival chances across an entire community. Seasonal maintenance was essential to preserving these systems. Before winter, walls were reinforced with fresh turf, roofs were repaired, and floors were compacted anew. Cracks that allowed cold air to penetrate also allowed heat to escape, undermining months of careful thermal management. These repairs were acts of engineering as much as maintenance, ensuring that the stored heat of stone and earth could perform its role when it mattered most. The psychological dimension of heat storage should not be underestimated. Vikings lived with an acute awareness of warmth as a finite resource. This shaped behavior, encouraging cooperation, patience, and restraint. Doors were closed quickly, fires were tended carefully, space was shared rather than wasted. The home was treated not as a disposable shelter, but as a living system that responded to care and neglect alike. By the late Viking Age, these principles had become so deeply embedded in daily life that they no longer appeared as conscious strategies. They were simply how homes were built, how fires were lit, how people gathered. Yet, when examined closely, they reveal an advanced understanding of passive heating that rivals modern sustainable design. Thermal mass, earth sheltering, controlled ventilation, and energy efficiency are concepts celebrated today, but they were practiced intuitively by Viking builders 1,000 years ago. The legacy of this knowledge extends beyond archaeology. Modern architects studying cold climate housing increasingly return to the same materials and principles: thick walls, natural insulation, heat-absorbing surfaces, and designs that work with the land rather than against it. The Viking home, once dismissed as dark and smoky, now appears as a masterclass in resilience, proof that survival in extreme environments does not require constant energy input, but intelligent design, rooted in observation and respect for nature. In the end, Viking heat storage was not about defeating winter. It was about enduring it with dignity. Stone held memory of flame, earth offered steadiness amid chaos, water softened the edge of cold. Together they formed a quiet alliance between human ingenuity and the natural world. Through this alliance, families slept, children grew, stories were told, and life continued through the longest nights. What remains today is not just evidence of ancient buildings, but a philosophy of survival, one that understood warmth not as something to consume endlessly, but as something to be captured, shared, and preserved against the dark.